So one last day before we leave. Yeah, we'll get this out of the way. So how to prove A is contained in B? Well, first example, first idea is method of exhaustion. So, for example, let A equal the set -1, 0, and 1. Prove that A is a subset of C. It's really easy. Actually, even better yet. Let's just say A is a subset. Let's A equal that, and B equal, let's say -2, -1, 0, 1, something like that. Our goal is to prove that A is a subset of B. Proof? Notice that, so really what we're trying to prove here, right? This is a statement that this says that for all X in A, X is in B. Literally, that's what this subset means. This is how it's defined. It means for all X in A, X in B. So proving a universal statement. So let's note that if X is an element of A, then X equals -1, X equals 0, or X equals 1. So let's split into cases. Case 1, X equals -1. Then, since -1 is in B, just by looking at it, X is in B. Case 2, we have X equals 0. Then, since 0 is in B, X is in B. Case 3, X equals 1. Then, since 1 is in B, X is in B. Thus, by method of exhaustion, for all X in A, X is in B. Look at me. For all X in A, X is in B. Thus, A is contained in B. Kind of went quickly, but that's because I think this part was obvious, right? This is method of exhaustion proof. You literally just go through every element and check it works out. Clearly, what's the problem we're going to run into here?
Well, there's infinite cases with infinite
What if we have
sets.
infinite sets, right? Like, what if A is infinite? What's going to happen? That's what we'll do next time. You can mull it over, but I think you guys know where it's going. Anyway, any more questions?
Can I talk to you about something after class?
Sure.
Okay.
Anybody else? Well, have a great Monday, everybody. Enjoy your last week for Thanksgiving break. Your last week of hybrid classes or anything, because after that, we're going online for 2 weeks, aren't we? Look at that. You guys sad or happy?
I mean, all my stuff was online in the first place, so it doesn't really change.
Oh, that's nice, Safa.
Take care, Professor.
You're welcome, Safa.